Hi everyone, in this particular video we will be discussing about Kafka. So Kafka is a very highly scalable distributed event streaming platform which is kind of open source. It was originally developed at LinkedIn but got open source in 2011. It works on a pub sub model where you have a publisher and a subscriber. So publisher publishes the messages and subscriber pulls or reads the messages. That is your basic pub sub model, and this is managed by a broker which we will discuss further in the video. So then it is designed for a real-time message processing. So and basically you can have high throughput and fault tolerant mechanisms for Kafka, which makes it highly robust, battle tested, and a lot of organizations have already adopted Kafka, and it's a very important technology in an event driven architecture where you can do a lot of analytics on the real-time events that are happening. So let's move on to the basics of Kafka components, which I have listed here in the terminology. So these are the basic components that makes up the Kafka ecosystem or its architecture. So you have a producer. So producer is kind of responsible for producing the messages. So it could be a message from a, let's say, a microservice, and which has like a topic name. So topic name would be registered in a broker, and whenever producer is producing the message, that Kafka it would be a structure. You can say that it will mention a topic name, the partition key, and the timestamp and the payload. So that data the producer will produce to a Kafka topic. Okay, simple. And then you have a zookeeper. So zookeeper is like a cluster manager, and it is used for managing the different Kafka brokers that are existing in a cluster. And basically it is like manages the Kafka brokers. Zookeeper is deprecated as of now, and the Kafka ecosystem has adopted KRaft, which is runs on a Raft protocol, and KRaft consensus algorithm. We will discuss that, like what were the issues and why Zookeeper is sort of deprecated. Now the third point is the broker. So broker is an important entity because it acts as a bridge between your producer and your consumer. And Kafka basically has those servers which are running, and which are called brokers, and there would be topics and partitions which are covered with Kafka servers. So they kind of manage these topics and partitions within a broker. Why do we have multiple brokers? Obviously to replicate it, and we have a leader and follower concept in brokers. So there's a leader which takes up the rights, and there are followers. So let's say if one of your broker goes down, then the another one can take over, right? So it makes it highly fault tolerant. Yeah, that is brokers. Now we will move to the fourth point, which is topic. So topic is a particular category of message, right, or an event. For example, you are booking. So booking is one event. Then you are doing a payments is another event. So we are categorizing it into topics, and there could be various consumers which can subscribe to that topic. Okay, so that is your topic. Now we will move on to the another section, that is partitions. So a topic is basically divided into multiple partitions. Why we do this is because Kafka is distributed in nature, and to concurrently and parallelize the request to make it highly efficient, we have this partitions, right? So they can get the events accept the events. Yeah, that's pretty much about partitions. Now we have offsets. So offset is the unique identifier which you assign. Okay, so we assign basically some unique identifier so that the consumers knows that at which point it has read the data from the given partition. So they will keep on committing their offset that I have read the data from this point, and even the producer will commit that I have published the data at this point. So that at any given of point of time, you know that whether the consumer is lagging or not, right? So that is the purpose of offset. So that is how Kafka ecosystem works in terms of producing and consuming of the messages, to keep that history kind of thing, that how many messages have been read at till what point, and if let's say a consumer goes down, then another consumer will come up and read from the next offset. Make sense? Okay, good. So that is what we are talking about offsets here. Then you have consumer groups. So obviously if you have a single consumer, then it's not going to work out, right? Because the volume is high. So you need to have multiple consumers, and again you divide all the consumers in a single group, that is a consumer group, right? So that the workload of reading the messages is divided and parallelism is also achieved. That is the purpose of consumer groups. And one important thing highly to note, which can come in your interviews as well, is that within, let's say you have two consumers in the same consumer group, then can they read from the same partition? The answer is no, right? Because that could affect the sequencing and ordering of the messages. So that is why we can have two consumer groups, right? So two consumer groups, and two consumers within different consumer groups can read from the same partition. That will have why would that happen? Because each consumer can have its own offset, and they can say that I have read data from this point to this point, and I have read data from this point to this point, right? That is the two consumers will maintain that. So basically that is the purpose of your consumer groups. Okay, and yeah, what are consumers? So that is pretty simple. They are responsible for reading of the messages. So this was the basic terminology. Yeah, so let's move on to the next section, that is why Kafka and KRaft, right? So it's quite interesting. Why? Because Kafka is very durable, right? It is like provides you mechanisms where, let's say if a consumer goes down, then you can read it from the next uh, set of offsets, making it more durable. You have the concepts of parallelizing the processes, right? So it makes it highly fast, right, and scalable. It's horizontally scalable, so you can add multiple brokers, you can have partitions, right? You can increase the number of partitions, and everything is configurable. So that makes Kafka very resilient and scalable system, and which is highly important in event driven architectures, where you are sending logs, right, from different microservices, and you can do basically real time analytics on that as well, right? So large organizations where the scale is in millions of events are getting triggered every second or every hour, then Kafka is a great choice there. It also provides you rewind and replay of messages. Okay, and it gives you message order guarantees. You have this concept of partitions and offsets, so that guarantees, right, that it's sequential, right? So offsets are sequential, so it will kind of give you the guarantees that the messages are delivered in order. Now we will discuss about another topic, that is KRaft. and why we adopted it, and why we are moving away from Zookeeper. So Zookeeper was kind of becoming a bottleneck for Kafka's scalability, where you have, let's say, trillion of events or billion of events. So then Zookeeper has to manage the metadata and stuff around that, and that makes it a bottleneck. And so basically Kafka has decided to move to Zookeeper from 3.x. It will support Zookeeper at 3.x, but in future versions it will be deprecated. So that is about the Kafka scalability. So one more important thing is, let's say if your Kafka Zookeeper goes down, then your cluster becomes useless. You cannot use it, right? Why? Because your manager is down, that is your Kafka manager, Zookeeper. Okay, so that doesn't make sense, right? So why don't you have a single responsibility assigned to a KRaft and within the Kafka ecosystem, that is making it more secure, reducing the operational workload, and even if you want to release something or managing or updating the metadata, then it becomes more easier because you have it within the same system, right? So that is the purpose of your Raft protocol or KRaft consensus algorithm, which makes it more efficient and resilient as well. So that is how we discussed about KRaft. We will discuss it about more in detail in further videos to discuss about KRaft algorithm or Raft protocol. So yeah, let's move on to the Kafka architecture. So this is the basic architecture of Kafka, and let's take a look at it, how things are working. Actually, we covered most of the things in terminology, but feel free to go through each of the terminology again and come back to this diagram to understand it more better. So I'll go like how the things are happening. So you have a producer, right? Producer 1, producer 2, producer 3. There could be multiple producers which are producing the message. So let's say a producer 1 produces a message to topic 1 or topic name, partition key, headers, and timestamp. Timestamp is nothing when the event got triggered. Okay, headers can be an optional field, and even partition can be an optional key, right? By default it can take some partition, but that's okay, you can send a partition key as well. Then there is a Zookeeper, which is kind of deprecated, but let's since it was in the original architecture, let's include it in our design. So you have your Zookeeper, which is kind of a cluster manager. Then you have a broker, right? So each broker can have multiple topics running in it, that is topic 1, topic 2, topic up to n number of topics, right? Then we are kind of dividing this topic into partitions. So these are partition 1, then you have partition 2, right? And partition n, right? There can be multiple number of partitions for a given topic. So basically a message is coming to a topic and it is residing into a partition. Okay, so what we are trying to say is that basically partition is the actual disk space where your message is getting stored, and each message when it is getting stored is given an offset: offset 1, offset 2, offset 3, offset 4, offset 5, offset 6, right? This is how your offsets are getting divided. And then similarly you have a concept of replication here, where you have a broker 1, broker 2, right? And you have one leader, which is broker 1, and there could be some followers following it, broker 2, broker 3. As much as you need, you can configure that in your Kafka. Then you have consumer groups. So within a consumer groups you can have multiple consumers that are running, which I have labeled as consumer 1, consumer 2, and there could be consumer n, right? So what is happening now here is producer is producing a message and consumer is going to consume the message. Now what happens? Now consumer 1 can do a commit that I have read from, let's say consumer wants do a commit here that I have read till 3, okay, till offset 3. Makes sense? Then what happens here is that once consumer 1 commits that I have read from offset 3, and let's say consumer 1 in consumer 2 is trying to read it from the same partition, okay, then what happens, it can also commit that I have read till 5. Okay, so what I'm trying to say here is consumer group 1, consumer group 2 can have consumers which could be reading from the same partition, but how Kafka knows that which consumer has read till which point, right? So here basically we are using offsets to track which consumer has read from which partition and till which point. So please note here that within the same partition, basically one partition can be read from two consumers in different consumer groups, right? So that will help you in achieving parallelism and it makes the reading faster, okay, and concurrent reads can also happen, right? So this is all about the Kafka architecture and Kafka ecosystem. So if you like this video, please consider subscribing the channel and like, share and subscribe. It will help the YouTube algorithm to reach to users for whom this video might be helpful.